Hello and good day, pre-algebra. Here with you, PO72. Normally I'm using the very cheery green color, but I left that in my van, so you get red today. Red or blue? What would you rather have?
Red.
Raise your hand for red. Raise your hand for blue. All right, blue it is. The people have spoken. Okay, so determining the probability of compound events. A compound event, we know what compound words are, right? What are compound words? What are compound words? Yeah. Right, two words kind of put together, okay? Backpack would be a compound word, I think, right? Back and pack together. So a compound event is two events we want to happen at the same time. Okay? Two events that we want to happen at the same time, or one after the other. This is the word events. Sorry, that's kind of messy. Two events that we want to happen at the same time, or one right after the other. Okay? So in order for a compound event to be successful, it has multiple successful outcomes, right? I should say two or more. Maybe the word multiple might be better. I'm going to change everything here. Multiple. I'm not used to this blue color. That's why I'm forgetting words here. Multiple events we want to happen at the same time, which require multiple successful outcomes, okay? And everything must happen exactly. So we've seen an example like this before where you got these marbles in a bag, okay? In this case, we have 8 red, 5 blue, and 7 white ones. And the question here is, what is the probability of choosing a red marble, putting it back, and then choosing a white one? Okay. The reason why this is considered a compound event because there are two things that we're looking to happen. It's not just picking a red one. It's picking a red one and then picking a white one. So if we pick a red one first and then a blue one, were we successful? No. If we pick a red one and then a second red one, were we successful? No. If we pick a blue one first and then a white one, are we successful? No. We're only successful if we pick a red one and then a white one. So multiple things happening here. And how you look at this is we can think about the individual probabilities first. What is the probability of choosing a red marble? Just a red one. 8 red marbles in a bag. If you add all those numbers together up, there are 20 total, 8, 5, and 7. So what's the probability of just picking a red marble? Aiden? 40%. As a fraction, please.
40 over 100. Or 8 over 20.
Yes, thank you. Okay, so the probability of just a red one, and we could simplify this, we could write it as a percentage, there's a lot, but we're going to keep it just as this for now. The probability of choosing just a red one is 8 out of 20. 8 red marbles, successful outcomes out of 20 possible outcomes. Okay, then we look at what is the probability of choosing just a white one. Don't worry about red. The probability of choosing just a white one. 7 out of 20, right? Because there are 7 white ones. You did put the first marble back. That's important. Okay, so there are still 20 marbles in the bag for your second pick, 7 of which are white, so you have a 7 in 20 chance. And then to find the probability of both of these events happening together, we take our two individual probabilities and we multiply them. Okay, we take the probability of a red, the probability of a white, and we multiply them together because we want them both to happen. So multiplying fractions, a little bit of review here. How do you multiply fractions? Some of you taking some mixed review retakes probably came across this. Yeah. You multiply straight across. Okay. 8 times 7 is 56. 20 times 20 is 400. So kind of tying back to 68 here, the theoretical probability of choosing a red marble and then a white one is if you did this 400 times, you would be successful 56 times, theoretically. Does that mean it's guaranteed to happen that way? No, right? Because that's theoretical. And then you could simplify this. You could write this as a percentage. Let's write this as a percentage. 56 divided by 400. So we're going to convert it to a decimal first. 56 divided by 400 is 0.14, which equals 14%. So you have a 14% chance of this compound event happening. Likely or not? Not likely to happen, okay? On average, 14 out of 100 times, again, percent meaning out of 100, 14 out of 100 times, this is going to occur, okay? Questions on this? Right? Compound words, two words put together. Compound event, two individual probabilities put together with multiplying them. It's essentially what's going on here, okay? Let's look at the next one. What is the probability of choosing a blue marble, replacing it, and then choosing a red one? So again, we're looking at the individual probabilities first. What is the probability of choosing a blue marble? Same bag, same numbers, everything. What's the probability of choosing a blue one? Well, I can't call on all of you at once, so some of you can put your hands down. Not all of you put your hands down. Aiden. 5 out of 20. There are 5 blue ones out of 20 possible. So the probability of picking a blue one is 5 out of 20. What is the probability of choosing a red marble? I shouldn't put, well, yeah. Probability of choosing a red one. Kira. Still 8 out of 20. And our denominator here is still 20 because we put that first marble back. You really need to pay attention, and we'll come across this a little bit further down the page here, whether you replace the marble or not. If you put it back, there are still 20 marbles in the bag for your second draw. If you don't put it back, well, then things change a little bit, right? So 5 out of 20 for a blue one, 8 out of 20 for a red one. To figure out the probability of both of these things happening, we multiply the probabilities together. We get 40 out of 400. Again, 5 times 8, 40, 20 times 20, 400. This decimal value, 40 divided by 400, is 0.1 or 0.10, which is 10%. Okay? So a little bit less chance of picking a blue and a red one versus a red and a white one, which makes sense because there aren't very many blue ones in the bag. So if we want to pick a blue one, which is less chance happening than red or white, it's going to drop our overall percentage a bit as well. Questions on this? Would you ask them if you had them? Okay, good. All right. I'm going to move that over there. Moving down the page a little bit. Let's go to one where we are not replacing it. The fourth one down, I believe here. What is the probability of choosing a blue one, not replacing it, and choosing a red one? So we just did blue and red up above, and we got 10%. The difference is, in that example, we put the first marble back. In this example, we don't. So how does that change things here? What is the probability of picking a blue one? That's still going to be 5 out of 20. And the probability of choosing a red one, there are still 8 red marbles in the bag, but if we don't put that first marble back, how many marbles are left? Carly? Only 19. So instead of 8 out of 20 in this example, it's going to be 8 out of 19 because one of those marbles has been removed. Okay? So our numerator is still the same. 5 times 8 is still 40, but our denominator, instead of being 400, 20 times 19 is 380. Right? So then, when we divide this, 40 divided by 380, it gives us a little bit longer decimal, 10.5 it rounds to, 0.1 0.05, which is equal to 10.5%. So by not putting that marble back, it doesn't change it much, but it does give us a little bit better chance, 0.5% chance, more likely to pick a blue and a red one if we don't put that first marble back. Okay. Yes. Okay. If you wanted to round that up to 11%, that would be okay, right? But you wouldn't just put 10%, because at the very least, if you're not going to put the 0.5%, this decimal right here would round up to 0.11 or 11%. So, how are you feeling? Okay? Decent? Okay. I'm going to give you some time to work on the rest of just this front page. Do show your work. I need to see these calculations here. And when you're done, just put your hand up and I'm going to come around and kind of take a look at things and see how things are coming along. So if you didn't show your work and you already finished the page, go back and show your work. Show me what you multiplied, right? So I can see that everything's doing right. So we'll pause the video and come back to it in a little bit. Okay, and we are back with audio, potentially. So we skipped this one here. Let's go over it now. What is the probability of choosing a white marble, replacing it, then choosing a white marble? So for those that missed the first part of the lesson here, we're dealing with compound probability. And we kind of compared it to compound words, right? A compound word is when you have two words put together, right? Right, Will? Yes, compound word, two words put together. So what we're doing here is we're taking the two probabilities that the question's asking for and putting them together to get the probability of both things happening. So the probability of choosing a white marble is what? 7 marbles in the bag, or 7 white ones in the bag out of 20 total. You have a 7 out of 20 chance. Now it's important to note that you put that marble back. Right? So there are still 7 white marbles in the bag and still 20 total marbles in the bag when you reach in for your second pick. Okay? So these two individual probabilities, we're multiplying them together, and the probability of both events happening is a 49 out of 400 chance. Okay? 49 out of 400 chance. Which is approximately 12%. Okay, we talked about in the next one that picking a blue one, not putting it back, and then picking a red one. What changes is the denominator here, right? If we don't put that first marble back, there are no longer 20 marbles in the bag. There are now only 19. And then the next one made things even more interesting, where I'm asking for 2 red ones without replacement. So you reach in the bag the first time, there's an 8 of 20 chance you pick a red one, but if you don't put that marble back, now what changes? Not only your denominator, because there are only 19 marbles left, but also your numerator, because you're looking for a second red one. And if you already took a red one out of the bag, there are only 7 red ones left. So this would be a probability of 56 out of 380, which would that work out to be percentage-wise? 56 out of 380 is about 14.7, so rounding up to 15% chance. Okay. And the last one, we have a compound word, 3 words together. 3 probabilities at the same time. The probability of choosing a red, what's the probability of choosing a red? Annika? 8 out of 20. And it says at the end of this here, so if you didn't read the whole question, maybe you missed it, but without replacing them. So we're not putting any of these marbles back. So for our second draw now, what's the probability of picking a blue one? 5 over 19. And then to pick a white one, John? 7 over 18, right? Since we're not putting any of these marbles back, our denominator decreases by 1 each time. So 8 times 5 times 7, 40 times 7 is 280. So there are 280 successful outcomes out of a possible 6,840 outcomes, right? There are 6,840 different things that could happen reaching into this bag and doing this test. Okay? 280 of those are successful. So 280 divided by 6,840 gives us a nice long decimal, which we can round to 0.04, which is a 4% chance. Okay? So if you try this 100 times, theoretically, you'll be successful 4 out of those 100 times. Or breaking down that fraction, 4 out of 100, 1 out of 25 times. But again, that's the theoretical. Okay? Will it actually happen that way? Well, that's why you got to test it, but we're not going to. Okay? All right. Any questions on... Well, don't move your chairs yet. It's so loud. I'm still doing stuff. Just sit still. Just hold on. All right, your homework for tomorrow. I'm going to assign 2 assignments on Khan Academy. They are due tomorrow before class. That is how you math.
Don't forget
To like and subscribe.